Hello students and welcome to Subnetting versus VLSM. In this video I'm going to teach you how to subnet, but before we get started I thought it worth making note of the difference between the two. Although both are used to split networks up into smaller networks, subnetting is always used in order to split networks up into equal-sized networks. Every one of the networks will be exactly the same size, and it uses a formula of 2 to the power of the host bits borrowed. So make sure you make this distinction, host bits borrowed, versus when we're using VLSM, we're using 2 to the power of the host bits reserved. So this subnetting formula works this way, creating more network bits depending on how many host bits we borrow, whereas this one is reserving host bits to ensure that we have enough addresses for our needs. They are both used still to this day. Many times what you'll see is perhaps a large organization taking a major subnet and splitting it up in this fashion, giving a very large portion of it to one West Coast and another large portion to the East Coast. These two are exactly the same size, and they start and end exactly where the original one started and ended. So you'll notice this goes all the way through 10.255.255.255. This one right here ends at 10.255.255.255. So you'll always find that subnetting uses all of the network when it creates multiple subnets, regardless if it is 2 subnets, 4, or 8, or however many that you create. Whereas VLSM, of course, we can now use VLSM in conjunction with our subnetting routine to perhaps start splitting out our subnets off of the major subnet that was assigned to the West Coast here to more along the lines of end user needs and major networks that can then be split down into smaller and smaller networks to service just the clients that we may need in a particular region. So you'll see that the two, subnetting and VLSM, are often taken together. So here's an example. If we take a 24-bit network and we have one network that's a 256 range, we can tell there are 256 addresses in here. If we borrow one host bit, so if we take this host bit right here and turn it into a network bit, that's borrowing one host bit. 2 to the power of 1 gives us 2 networks. You'll see the 2 networks here, and you'll notice that this network started at 0 through 255, and this one starts at 0, goes through 127, and then 128 through 255 to give us exactly the same number of hosts in each subnet. Had we stolen one more bit, you'll notice that when we steal another bit, if we borrow 2 bits, 2 to the power of 2 is 4, there's the 4 networks, and you'll notice they still start and end at exactly the same place that our original network started and ended. And if we continue on down, you'll notice we continue to create networks of exactly the same sizes. If we borrow 3 bits and turn those 3 bits, host bits, into now network bits, we would create 8 networks. And there's the 8 networks across, again starting at 0 and running their way through to 255, the same exact range. So we can also see this hold true in a 16. If we pull 1 bit from the host, we create 2 networks again. The only difference this time is the octet, where this range occurs, is no longer on the 4th octet. It is now on the 3rd octet. So you'll see we move from a 16 by borrowing 1 to 2 17s. But again, this range up here originally was 0.0 through 255.255, and you'll see this subnet starts at that and this subnet ends at that. So exactly the same networks, exactly the same size, 32,768 addresses in each one. And as we continue to move on down, the same holds true. 2 to the power of 2 gives me 4 networks. There's the 4, and again they start at the same place and they end at the same place. So you can see the range is even the same in this example as it was in the previous example with the /24. It's just moved over to a different octet. It's moved to the 3rd octet instead of the 4th. So finally we can see 2 to the power of 3 bits gives us those networks with 8,192 each. So, how do we get started? First and foremost, make sure you start at a valid starting line. And what do I mean? 10.3.0.0/8 is not a network. Don't be fooled. The network is actually 10.0.0/8. 192.168.0.64 with a 25. A 25, the bit positional value is a 128. Therefore, the network can't start at 192.168.0.64. It must start at 0. Remember, it's all in the bit positional value. So when you're looking down through these networks, make sure that you ensure that once you have found the slash notation for whatever network that you're working on, you then want to associate that slash bit. What is the bit positional value of the 17th bit in this case? And in this case, the 17th bit's bit positional value is a 128. And that gives you the range of each one of these networks. Of course, this time it's on the 3rd octet. You're just trying to find the bit positional value once you determine what your last network bit is. So here, if we had borrowed 2 bits, again that would have given us an 18. And when we look at a 18 for the bit positional value, its range is a 64. And again, it's on the 3rd octet, so you'll see the range of 64 on each one of these as we move along. But you must make sure you've started a valid starting line. So make sure that you understand that some of these network addresses that you'll be given are not actually the start. 172.64.0.17, that's not a network. The network's actually 172.0.0.0. Again, the 17th bit is a range of 128, so it must start on the 2nd octet at either 0 or 128. One like this one can really get you. 192.168.15.0 with a 23. That's not a network. That's a range of 2. The last bit is the 23rd bit. The bit positional value of the 23rd bit is a 2. Therefore, the network here is actually 14.0, which would include 15.0 as an address. So you must start with a valid network ID. If you're unsure how to perform this very important task, I've got another video on YouTube that determines how to determine the network ID when given an address and a subnet mask. Make sure you start at a valid starting line. So here's an example. 10.0.0.0/8, we need 4 networks. Make sure it's a valid starting point. This is. Determine host bits available. In this example, we have 24 host bits available to us. We're trying to get 4 equal sized networks. We're doing subnetting. Use the formula 2 to the power of y equals n. Determine the networks required, and that's been given to us. Plug it into the formula. Solve for y, and in this example we solve 2 to the power of y equals 4, and we find that y equals to 2. So that is the number of host bits that we must borrow and turn into network bits. So we'll borrow, we already had 8, so we're going to borrow 2 more to give us a /10. And then we find the bit positional value of that last network bit. It's a 64, and it's on the second octet. We can now write out each one of our networks and use 64 as our range to go from one to the next, and we always start exactly where our base started. So you can do this very easily by hand. Let's take this one, and you should do this on paper until you get used to doing this step. So the easiest thing to do here is we have our address here. So there's our base. We know how many networks we need. So we'll plug it into our 2 to the power of y equals n and 2 to the power of y equals 4 because the number of networks is known. So 2 to the power of y, or y equals 2. So we need to borrow 2 host bits. Solving for y. So y equals 2 host bits. So write out your network that you started with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This is network, 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 and we're going to borrow 2 host bits to turn those into network as well. So we'll go from a 24 to /26 on all 4 networks. We can go down now on our paper and write 26, write it 4 times. Go back up to our base, start with our base. Determine the bit positional value of this last network bit, and in this case it equals 64. Determine which octet it's on. In this case it's the 4th octet. So we'll just add 64 to the 4th octet on each one. And then the remainder is the same. And if we wanted to do this again, we could do it for 2 networks. Same process. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And this time we're solving for 2 networks. So 2 to the power of y equals 2, y equals 1. So we must borrow 1 host bit. So we'll turn this 1 host bit, and now instead of having /24s, we will now have 2 /25s. Then we just determine the bit positional value of that last network bit. It's a 128, and in this case it's on the 4th octet. So we'll start with our base, 172.16.0.0, and add 128 to the fourth octet to get to the next network. And if you'll follow this step process every time, it's very difficult to go wrong. Once you have the next networks, you can then begin to work backwards one to find the broadcast address for each one. Hope this helps you learn how to do subnetting. Good luck.